Friends, welcome to my YouTube channel. Dhanesh here. We were discussing with exploratory data analysis in the last video. In this video, I am going to discuss what are the differences between univariant analysis and bivariant analysis. Let's start. I believe this is the 12th video on feature engineering and the third video on exploratory data analysis. Let me give a quick introduction to feature engineering. In feature engineering, we convert data into features. We are converting data into features. That's what we do under feature engineering. These are all the different steps we need to follow under feature engineering. The philosophy of feature engineering is the quality of your inputs decide the quality of your output. As far as the data scientist is concerned, 80% of his time is spent on feature engineering. So you can understand the importance of feature engineering. This exploratory data analysis is is part of feature engineering. So the steps coming under feature engineering is variable identification, univariable analysis, bivariant analysis, missing values treatment, outlier treatment, variable transformation, variable creation. Videos are available about these different steps. Videos are available under the playlist feature engineering and statistics. There are two playlists created, feature engineering and statistics. You can see all these videos under these two playlists related to univariant analysis, missing values treatment, outlier treatment. Everything is there. Let's continue. See, I'm giving some idea about exploratory data analysis. It's very important. EDA is a set of statistical approaches to explore and understand data. There are mainly three kinds of analysis done in EDA. One is univariant analysis, bivariant analysis, multivariant analysis. We have videos on univariant analysis and bivariant analysis under the playlist EDA, exploratory data analysis, and you can see those videos in feature engineering as well under the playlist feature engineering. Fine. See, what is univariant analysis? I'm comparing what is the difference between univariant analysis and bivariant analysis in this video. Univariant analysis is the simplest form of statistical analysis. Uni means one. That means your data has only one variable. It doesn't deal with causes or relationships, and its major purpose is to describe and takes data and summarizes that data and finds patterns in that data. Here only one variable is coming into picture. So there is no analysis of the relationship between variables. As part of regression, we normally focus on the relationship between two variables. That won't come here because there is only one variable. When we compare with bivariant analysis, this type of data involves two different variables. That's by bivariant analysis. And bivariant analysis find out the relationship between two variables. For example, you have two variables. Let me give the equation y is equal to mx plus c. Here x is the independent variable and y is the dependent variable or the output variable or target variable. X is known as the independent variable or predictor or the input variable. You know these concepts, and m is the slope and c is the y-intercept. Bivariant analysis finds out the relationship between two variables. We can perform bivariant analysis for any combination of categorical and continuous variables. You know, variables are of two types. One is categorical variable and another one is continuous variable. Continuous variables means, example I can give height of the students in a class, weight of the students in a class, or categorical variables means gender, whether male or female. It is a categorical variable. See, some students appear for the exam, the result, whether pass or fail. These are all categorical variables, you know those. So the combination can be in bivariant analysis. There can be different combination, categorical and continuous, and continuous, because two variables comes into picture, their combination. There are three type of combination we can get it. So different methods, different treatment we will give for these different combinations. I will discuss that as well. Example of univariant analysis. Example of a univariant analysis is height. It's in centimeter. See this data. It's an example for univariant analysis. Example for bivariant analysis, because this is the temperature. The temperature and ice cream sales. As temperature increases, ice cream sales increases. We can tell they are directly proportional. They are directly proportional. If one increases, another decreases, we will call they are inversely proportional. For example, pressure is inversely proportional to volume. Volume is directly proportional to temperature. See, as temperature increases, ice cream sales increases at 21 degrees Celsius. This is the data. So this is an example for bivariant analysis. See, univariant analysis, again, I am coming back to univariant analysis. See, I have given an example for bivariant analysis. I have given an example for univariant analysis. I told you what is univariant analysis and what is bivariant analysis. In univariant analysis, only one variable. Bivariant means two variables. See, what is univariant analysis for continuous variables? How we will do? And I will tell you how we will do for categorical variables as well. In case of continuous variables, we need to understand the central tendency and spread of the variable. Spread means dispersion. In physics, you might have heard of dispersion in light. Dispersion means the spread of data. And the central tendencies. The central tendencies are measured by using mean, median, mode, min, and max. See, all these things, it's very important from a statistical perspective and from a machine learning perspective. There are videos available for mean, median, mode, all these aspects. Please learn it. It's very important. And the measure of dispersion is, measured by the dispersion, the spread of data. Dispersion means the spread. Spread means, so I can give you two examples. One is the data, it is given it as 21, 22, 26, 25. It's not the spread is less here. I'm giving another set of data 15, 7, 20, 25, 96. The spread is more. So this is the difference. So the spread of the data is measured by range, quartile, IQR, interquartile range. Very important. I have a separate video on statistics under the playlist statistics, interquartile range. You can check it, and under feature engineering. Standard deviation, separate video is available. Skewness and kurtosis. So these are all the terms we use to measure the dispersion or spread of data or scattering of data. For visualization, we have histograms, box plot, and violin plot. These are all the three, visualization methods. Box plot or whisker plot. Box plot is also known as whisker plot. WHISKER. Whisker plot. There is a separate video for box plot. We will use it for detecting outliers. So you have a separate video under the playlist, feature engineering, box plot, it's there. So these are all the visualization methods we use for univariant analysis. Now I am coming to see, this is for the continuous variables, univariant analysis for continuous variables. When it is categorical variables, for categorical variables, we will use the frequency table to understand distribution of each category, and the visualization methods we use here are the pie chart and the bar chart. Very important. We will use the pie chart and bar chart. So we have separate videos, for in the playlist. You can watch those videos, pie chart and bar chart for univariant analysis for categorical variables. Now I am coming to bivariant analysis. See, you need to understand, for bivariant analysis, I told there are two variables. I have given the example, the temperature and the ice cream sale. And I told you the bivariant analysis, there are three types of combinations. One is the numerical, and numerical, because the two variables both can be numerical, both can be categorical, and both can be numerical and categorical. So what are all the approaches? How do we analyze it? When both of them are numerical, we will go for the correlation coefficient. It's an important term in statistics. We have the video under the playlist statistics. This standard deviation, correlation coefficient, it is also known as Pearson correlation coefficient, covariance. All these things are very important. Please learn these terms. If you don't know, then the categorical, both the variables are categorical, we will go with chi-square. This is another thing, chi-square. I will be preparing videos for chi-square, t-test, z-test, ANOVA. This is, if one is numerical and another one is categorical, we need to go for t-test, z-test, or ANOVA. These three we need to learn it. I will be preparing the videos and put it in the same playlist. You can watch within 2 days. I will be doing it. So this is about the bivariant analysis. So these are all important for numerical variables. You have to go for correlation coefficient. If both of them are categorical, chi-square, numerical and categorical, you need to go for t-test, z-test, and ANOVA. Then, so that's all about the comparison between univariant analysis and bivariant analysis. Thanks for watching. Please like, share, and subscribe. Thanks a lot.